Okay, Algebra 2. Here we are with some extra problems to get you going today on your homework. Alright, we talked about yesterday graphing three inequalities and shading. One of the new things for today is that some of these problems are going to ask you to find the coordinates of the vertices of that triangle. Okay? And sometimes that works out real nice and sometimes it doesn't. Okay, so let's start you off with something like this. So x is less than or equal to 4, y is greater than negative 3x plus 12, and y is less than or equal to 9. Okay, so it's a pretty easy one, because we have two straight lines, like two lines that are vertical or horizontal. Okay, so less than or equal to 4. 1, 2, 3, 4. Solid line. We're coming straight down. Less than, going to be to the left. Okay, real light over there. Y is greater than negative 3x plus 12. So 10, 11, 12 would have been up here. Okay, then if I go over 1, down 3, or down 3 over 1, 1, 2, 3 over 1, 1, 2, 3. Okay, and this is going to be a dotted line, because it's greater than. Alright, and we're shaded above. And then our last one here, less than or equal to 9. 11, 10, 9. That's going to be horizontal going across. And we can see where our triangle is. Okay, and so this one worked out pretty nice. Okay, it was nice and easy points. Real obvious ones. Okay, 1, 9. 4, 9. And we had 1, 2, 3, 4, 0. Okay, pretty easy stuff. What happens when we don't have such nice ones? What happens when we don't have such nice ones? Okay, let's take a look at that. Where's a good one here? And 2y plus 5x. Okay, so we have that. Alright, so the first one we might be thinking cover-up method, right? Cover-up method, we're going to cover up the 4y. My x would be negative 5. And my y would be just under 4. So let's try that. Negative 5, 1, 2, 3, 4, 5. Okay, and then 15 over 4 is going to be 3.75. Just under the 4. Okay, solid line. And we would shade it below. Okay, second one. 2y plus 5x is greater than negative 2. This time the y works out nice. Cover up the x. Y would have been negative 6. And cover up the y. We'll have negative 2.4. And that's going to be a dotted line. Shaded above. Okay, and our last line here, we got to do a little work. Got to move this over. 10y minus 27x greater than or equal to negative 60. I subtracted the 27x over, subtracted the 60 over. Okay, so my y would be negative 6. Ooh, got that same point. That's nice. I know where one of my corners will be. And then x would be just over positive 2. And this is another solid line. And shade above. So here's our triangle. Okay. Now, this one had one really nice one that I know it started there because I remembered the y-intercept was negative 6 on one of them and the y-intercept was negative 6 on another one, so I know that's the point. 0, negative 6. Okay. This one, it looks like it's going to be 1, 2, 3, 4, 5, comma 1, 2, 3, 4, 5, 6, 7. It looks like it's going to be 5, comma 7. Okay, but I don't know. You don't know 100% for sure. And this one's some sort of decimal over here. Okay, now what to do? All right, so how to make sure we know what it is for sure, we need these to be in y equals form. Okay, so this one, we're not using this anymore. Well, we can leave it there. Okay, this one's going to be 4y less than or equal to 3x plus 15. And if you divide them all by 4, 3/4 x plus 3.75. Okay, the second one. 2y greater than negative 5x minus 12. Y is greater than negative 5 halves x plus, minus 6. And then this one. Okay? We'll have 10y is greater than or equal to 27x minus 60. And divide everything by 10. Y is greater than or equal to, do we just go the decimal? 2.7x. 27 divided by 10, 2.7x minus 6. Okay? So these two I know cross down there. Got those two done. Okay? Next, probably we want to do this nice easy one. Where does that one cross with, so that one was the positive slope that was started at negative 6, cross with the one that has positive slope starting at 3.75. So positive slope, this one and this one. Okay, we can set those equal to each other and solve. So 3/4 x plus 3.75 equals 2.7x minus 6. Okay, 3/4 x is 0.75. All right. So let's add 6. So I have 0.75x plus 9.75 equals 2.7x. Subtract the 0.75x. So I got 9.75 equals 1.95x. Let's divide by 1.95. And we got a nice number, x equals 5. Okay, x equals 5. And then I can put that back up into either one of those and figure out what y was. Okay, that was the top and the bottom one. So 2.7 times 5. That should be 13.5 minus 6. Y is going to be 7.5. Okay, let's double check that with the other one. 3/4. 0.75 times 5 plus 3.75 would again be 7.5. Okay, so our other point way up there on the top was 5, comma 7.5. Okay, even though we thought that was 5, comma 7, it was really supposed to be 5, comma 7.5. So you got to be careful. Like I said, you didn't know that it was going to cross exactly there. We could have been slightly off on our lines, and that would have caused it to be just a little bit different. So these are actually going to cross at 5, comma 7.5. Okay, and then our last point we wanted, this one was going to be a decimal. At least we were thinking it was. I don't know, maybe these lines are off, and this is going to be a nice point. So I need that line there with the positive slope that started at 3.75, and then the negative slope at negative 6. So that's going to be our number 1 and number 2. So we got 0.75x plus 3.75 equal to negative 5/2. So that'd be negative 2.5x minus 6. Okay, now we got to solve this one. I'm going to add that 2.5x. Okay, and let's subtract that 3.75. So I got 3.25x equals negative 9.75. Divide by 3.25. Okay, and x is going to be negative 3. So that's going to be a nicer point than what we thought. Okay, x is negative 3. So I get to put that back up into either one of those. Negative 2.5 times negative 3 minus 6. That's going to be 7.5 minus 6, 1.5 for my y. So negative 3, 1.5. Okay, so we thought this one was going to be a nice one and ended up having a decimal. This one looked kind of crazy to begin with. Okay, and it actually ended up being not too bad, negative 3, comma 1.5. So there are the coordinates of our vertices of the triangle. Okay? Now, how about a little shortcut? How about if we use our graphing calculator? Okay? So if you get them all in the y equals form, you type all those into your calculator. I suppose we can see them right here, can't we? Okay, so I'm going to clear these all out. Alright, let's see here. 3/4 x plus 3.75. 3.75. Negative 5/2 x minus 6. And we went with just 2.7x minus 6. Okay, we can push a graph. Alright, so there's no shading on this because we didn't tell it to shade. That's a whole other process in here. It's going to cause more problems than it's going to solve, so we'll just let that go. Okay, if you don't have like the nice normal -10 to 10, -10 to 10 screen, you're going to push zoom down to 6, zoom standard. Now zoom to your standard screen, your -10 to 10 on the Y, -10 to 10 on the X. Okay, so I can see my triangle. That's good. All right, and I want to know where these two cross. So I'm going to do second, trace, intersect. Now it says first curve, second curve. Okay, we're not using curves, we're using lines. It's just programmed to ask you for curves. Okay, so it doesn't matter. All right, so you can kind of see the spider guy. He's over here. Yes, I want that line. So hit enter. Now the second curve, which one do you want to use? It's going to start it here on the same one. Hit down. Okay, that one, or which one do I want? Okay, you got your options. So just keep hitting up until it's on the line you want. Okay, so until it highlights the line you want. So I already picked this one. The second one I wanted was this line. Okay, and guess. It doesn't matter where you guess, but if you want to slide it over closer to the point, you can. It'll make like a millisecond of a difference. Okay, and those two lines are going to cross at 5, 7.5, just like we said. Okay, next you want to do this one. Second, trace, intersect. I want to know where those two lines intersect. Okay, first curve. Oh, it's blinking like right there. Like, how do I know which one that is? Okay, up and down will cycle through the lines. Left and right will move your little spider guy. So let me just hit left and see which one I'm on. Oh, okay, I'm on this one. Yep, that's what I want. Hit enter. Okay, now up and down to pick the second line. Nope, I don't want that one. Alright, the spider guy's gone. Where did he go? Okay, I'm going to hit left and right here and see if I can find him. Okay, back to that same one there. Hit down or up again. Oh, now I'm on this line. That's what I want. Okay, my guess. Like I said, it doesn't matter where you guess. And those two lines are going to cross at -3, 1.5. Okay, and our third time here, second trace, intersect. First curve. Where are we? Okay, nope, I don't want that line this time. First, yep, I want that line. Enter. Second curve. Nope, not that one. Not that one. Where'd we go? We're at -0.2, -6. That's going to be off the screen here maybe. Oh, here I come. There he is. Yep, that's the other line I want. And guess. 0, -6, just like we thought, okay? So you can use a calculator to help get those points a lot faster, all right? You need to put them into y equals form or get y by itself. Okay, if you want to do it by paper, you get a y by itself, and then you set those two equal to each other, get where your x is, okay? And then you could substitute that x back into either one of those two y equations that you're using, and you'll get your y, all right? If you're going to do it on graphing, you still have to get y by itself for all three of them so we can type it into our calculator. Okay, then we can go through that process using second trace, intersect, and then the calculator will do the work for you there. Okay, you should probably be able to do it this way at least once, be able to do it that way, and then once you've established you know how to do it this way, then you can use your calculator for a shortcut or to check your work. All right? Good luck, guys. Get that homework done. We'll see you tomorrow.